You could have just the number 2. It's a number. It's a monomial. You could have -2. That's a monomial. Should we just wait? We got popcorn popping in my video. Okay, let's keep going. How about this? What if we have -2xy squared? Does that meet the definition of a monomial? Let's read it again. A number, a variable, or the product of a number and one or more variables with whole number exponents. That meets the definition, doesn't it? That's a monomial. It's the product of a number and 2 variables with a whole number exponent. Yep. It's a monomial. Okay, how about this? Monomial or not? Be confident. Yes or no? Do you think it's a monomial? Why? It's not. Why is it not a monomial? Yes, because the exponent cannot be a variable. So this is not a monomial. Okay? Let me give you another one. 4x to the 1/2. Is that a monomial? Why not? Because the exponent cannot be a fraction, so it's not a monomial. Okay? And then I'm going to give you one more. Is this a monomial? Why not? Exponent can't be a negative. Okay? Now, as we move through this, you have to kind of remember the definitions. If you don't, you have to go back and read them until you're solid with this stuff. Okay? The degree of a monomial. It's the sum of the exponents of the variables. The sum of the exponents of the variables in a monomial. So, for example, here's a monomial. It meets the definition. What's the exponent in that monomial? 4. So the degree of that monomial is 4. How about this? A little bit tricky there. Oh, look how smart you are. They're saying that the degree of this monomial is 1 because the exponent's on the variable. What is the exponent that we just don't write? 1, right? So that means the degree of that monomial is 1. Degree is 1. Okay, so let's keep going here. Let's say we have this monomial, and we have to state its degree. Now remember the definition. It's the sum of the exponents of the variables. So yeah, this has a 1 on it. The x has a 1, so 1 plus 2 is 3. So the degree is 3. I'm going to put a 1 there. You can write it or not. It doesn't matter. It's just usually not written. That's a 1 right there. Okay. All right, now I got another one for you. It's a little tricky here. Okay, 7 is a monomial. What do you think its degree is? I want y'all to think about it. What do you think? The definition is the sum of the exponents of the variables in a monomial. So we're looking at this monomial. Are there any variables? So what's the degree? 0. Now let me show you a sideline as to why that is the case. Now I'm just going to draw like a little squiggly here. You don't have to write this. If I have this, 7x to the 0. Does anybody remember what anything raised to the 0 power, what's that value? 1. Anything raised to the 0 power is 1. So really this is just 1. 7 times 1 is 7. So that's why it's a degree of 0 here. Okay? All right. Okay, cool. Let's move on then. Polynomial. a monomial or a sum of monomials. Poly means many. Okay. Polynomial is like a blanket term. We can call pretty much anything a polynomial. And we have certain names for smaller polynomials. So for example, x plus 3 is a polynomial. It's the sum of two monomials. But x plus 3 could also be a binomial. A binomial is a polynomial. Binomial has two terms. So it can be called either. Usually we call it a binomial when it has two terms. Okay? All right, how about just y? Is that considered a polynomial? Sure. It's also called a monomial. Okay, so polynomial is like a blanket term. We could have this, y squared plus 4y plus 6. Okay, that's a polynomial. It's a sum of monomials. What's another word you think we might call that? A trinomial. It's got 3. So down here is a trinomial. It's a polynomial with 3 terms. I could just write that one from up there. So, to be clear, polynomial is a blanket term. You could have a monomial. It's also a polynomial. You could have a binomial. It's also called a polynomial. You could have a trinomial. It's also called a polynomial. After 3, they're just all called polynomials. Okay? All right. Or you might have something like this. Someday, you get to work with something like this. That's a polynomial, too.
I don't like that.
That would just be called a polynomial. There's no name otherwise for that. Okay? Just a bunch of terms together. Okay, now we talked about the degree of a monomial. Now we're going to talk about the degree of a polynomial when there's more than one term. The greatest degree of the terms in a polynomial. Now let's talk about terms. Terms are separated by plus sign. Terms are separated by a plus sign. So that means up here we have 1, 2, 3, 4, 5 terms, don't we? But somebody might say, yeah, but that's subtraction. Isn't subtraction just adding a negative? Yes, it is. Okay, so these are separated all by a plus sign. If you change that subtraction to adding a negative, it's a plus sign. Okay, so those are all terms. All right, so the degree. So let's say we have this. 5x to the 4th plus 3y plus 4. Okay, so I have these 3 terms. The degree of the polynomial is the greatest degree of the terms in the polynomial. So which term has the highest degree?
5x, 4.
Yeah. And 4 is the degree of this term. That's the highest one, right? Whatever the exponent is, basically. So that means the degree of the polynomial is 4. 5x to the 4th is the highest degree. So the degree of the polynomial is 4, whatever the exponent is. Okay? Yes?
Do you find out which one is the highest based on the exponent, or which is highest based on the base number?
Exponent. Okay? And again, sometimes you might have to add them together, like we did here. That is a degree of 3, right? So yeah, it's based on the exponent. Okay? All right, let's look at another one here. How about this? 2x cubed minus 3x squared y cubed plus 2y to the fourth. You have to decide the degree of that polynomial. It's based on the exponents. So which term has the highest degree? What is the highest degree? It's tempting to say this, isn't it? It's really tempting to say that. But you have to remember that in a single term, you add the exponents. So this term has a degree of 5. That's the highest. So that means the degree of the polynomial is 5. Okay? The degree is 5. Go back to these definitions if you can't remember things. You're learning it. It takes a little bit to learn it, okay? The degree is 5 for that one because 2 plus 3 is 5. Okay? All right, standard form of a polynomial. You write the terms in order from highest degree to lowest degree. So I'm going to put an A here and a B here. We're going to have two different examples that we're going to use in the next one too. So A, the first example I'm going to give you is this. Okay, so we have to write that in standard form. Meaning highest degree first. Which term has the highest degree? This one. So that's going to go first. Once I write it down, I like to cross it off, so I'm done with it. Then what would be the next one if we're going from greatest to smallest? Yeah, then we would write plus x squared. I wrote that one down. And then I would minus 3, because that has a degree of 0. So highest to lowest. That's standard form. Cool? Let's do another one. Oh, let's do this one. Let's write this one in standard form. What would be the first term that I would write here if I was writing this polynomial in standard form? Yeah. This has a degree of 5. That's the highest degree. So that's the one that I write first. Negative 3x squared y cubed. That's the highest degree term, so I cross that one off. What would be next? Yep, plus this one, 2y to the fourth. And then the last one, plus 2x cubed. That's in standard form. Highest degree to lowest degree. Okay? Pardon me? Okay, one more thing to talk about. Leading coefficient. We can't talk about leading coefficients if you don't know what a coefficient is. Does anybody know what a coefficient is? What do you think? What is it? Well, tell me this. What's the coefficient of this term right here?
-3.
Correct. It's the number in front of the term. That's a coefficient, -3. The coefficient of that one is what? 2. The coefficient of this term is 2. Okay? What's the coefficient of this term? 1. We just don't write that number in front of there. There's 1 y cubed there, right? There's 1 x squared here, so the coefficient's 1. So leading coefficient is the coefficient of the first term in a polynomial that is written with the exponents of a variable decreasing from left to right, or basically written in standard form. Has to be written in standard form, or the one with the highest degree. So let's use A. What is the leading coefficient of this polynomial right here? What number is in front of the first term? 1. I like to abbreviate LC, is 1 for A. I got that from here. for B. What's the leading coefficient? Leading coefficient is what? Of this one? -3. Okay. Binomial, trinomials. Binomial has 2 terms. Trinomial has 3 terms. They're just individual names for certain polynomials. Okay? All right, let's practice some of this stuff. Okay, write the polynomials in standard form. Identify the degree and identify the leading coefficient. Okay. Standard form means we put the highest degree term first, which would be which one? This one right here. So that goes first. I'm going to cross that off. Then what's the next degree?
5y.
Correct. Plus 5y. That's got a degree of 1. And then I'm going to add the 9. Okay. That's standard form. When I have to write the degree, I just put d. What's the degree of that polynomial? 2. It's the highest exponent. Highest degree term. When I have to write leading coefficient, I just put LC. What number is the leading coefficient for that polynomial? Yep, it's the number in front, -2. Okay, let's do this one. This is the highest degree, that goes first. And then I have plus 3b cubed. And then I have plus b squared. My degree is what? 4. It's the highest exponent. Okay, the degree is 4. The leading coefficient is what? -4. Okay, just to be sure, to be a polynomial, because you're going to be asked, are these polynomials? To be a polynomial, an expression must have no negative exponents. I'm abbreviating. No negative exponents. No fraction exponents. And no variable exponents. I'm going to add one more in here. No variable in the denominator of a fraction. Which ultimately will be the same as no negative exponents, but you haven't learned that yet, so they're really the same. Okay. Tell whether the expression is a polynomial. If it is a polynomial, find its degree and classify it. Classify it by the number of its terms. Otherwise, tell why it's not a polynomial. Okay, would this be considered a polynomial? Yeah, it's a monomial, which is a polynomial. So, yes. The degree is what?
3, 2,
Careful. Trust yourself.
3.
It's 2 plus 1, because there's a 1 on that x. Okay, so it's 3. And the leading coefficient is what? 5. Okay? Is this a polynomial?
No.
No, why not?
Negative.
Negative exponent. Is this a polynomial?
No.
No. Why not?
Fraction.
Fraction exponent. Is this a polynomial?
No.
Why not?
Variable in fraction.
Variable in the denominator. I abbreviated denominator, variable in denominator. How about this? Yes. What's its degree?
9.
It's 6. You just do this term, 5 plus 1 is 6. That's more than 3. So It's 6. And you know what? We did it wrong. We didn't really have to say the leading coefficient here. That's my bad. We just had to classify it. So how many terms are in this one? 2, so we could call it a binomial. That's classifying. Okay? It could also be called a polynomial. This one would be just a monomial. Okay, couple more things we have to do. Add or subtract. Be very careful about distributing the negative if it is a minus in front of the parentheses. Here, it's not a minus, is it? We're just adding all these like terms. So I'm just going to write it without the parentheses because they're irrelevant here. I don't have to distribute anything. They're just irrelevant. No parentheses. Now I got to combine like terms. Like terms have to have the same exponent value. So I'm going to start with the biggest exponent, which is x cubed. Correct? Do I have another x cubed? Right here, yeah? Oh, wait a minute. This one's negative, this one's positive. What happens to them? They cancel out, so they're not going to be part of my sum. So these cancel out. They're not part of my sum. You see that? Because they have the same exponent. Okay, now let's go to the squared. Is there another squared? Right here. They're exactly the same terms. So negative 2 plus 3. How many x squareds do I have? 1x squared, right? 1x squared. You can write the 1 or not. It doesn't matter. And then I have a 3x, which would be next, and there's nothing else to combine that with. And then I have minus 12. So I've done that. I want you to try this one. All right, let's do this one. Now you have a minus here. It's a little trickier. There's a way I should teach it, and there's an easy way to do it. You probably want to know the easy way to do it, right? Okay, what you have to realize, though, is this is really minus 1 here, correct? There's really a 1, we just don't write. And we would have to distribute that negative 1 through all of those. And ultimately what that does is it just changes the sign of everything in here, doesn't it? So just the easy way is to change this to a plus and change all of these to their opposite sign. Because you're distributing that negative 1. If you change that to a plus, you're distributing that negative 1. And then I'm going to kind of rewrite it so I can see what I have. Then I can combine like terms. You can change that to adding a negative as well if you want. Okay? So I'm going to add the 2c squared and the negative 3c squared. And I have negative 1c squared. And I'm going to cross those off so I don't get confused. Then I'm going to add the 4c. There is not another c. I can't add it to anything else. It's its own thing. And then I can combine these two. Go ahead. Okay? All right, you try this one. If you change this to an add, then you got to change everything inside there to its opposite sign. You change that to an add, you change everything inside here to its opposite sign.